Okay, for inscribed angles, we're going to go back to what a central angle is. Central angle obviously starts, goes to the center, and then comes back out. We've already looked at central angles before, that's not new. What is new is an inscribed angle. Can we see the difference between these two? What's the difference?
The
vertex goes from one part of the circle to another part of the circle and then back across. It never goes to the center. So an inscribed angle never goes to the center. It can go through the center, but it's going to keep going.
Just like diagonal radius. Like diagonal
Yeah. I could have this right here. That's still an inscribed angle. Even though it goes through the center, it's an inscribed angle. For a central angle, you go to the center and then you immediately come back out. We need to understand the difference between those two things. Central goes to the center and comes back out. Inscribed goes to the circle and then comes back out. All right, measure of a central angle matches the intercepted arc. If it's a central angle, whatever's inside is going to match whatever's outside. So arc AB would be how much? 80. It's got to be the exact same. If it's a central angle, they've got to match up and be the same. That rule we've already talked about. The new one is the inscribed angle. The measure of an inscribed angle is half of the intercepted arc. The angle is the small one. The arc is the big one. So this 60 is half of whatever this one is. So then that means it's got to be 120. If it gives you the angle, you multiply by 2. If it gives you the arc, you divide. All right, copy those down so we can go over them. All of these are inscribed angles, which means I'm either going to multiply or divide by 2. If it gives me the angle, what do? Multiply. So that means this part out here has got to be 100. If it gives you the arc on the outside, you divide. So 190 divided by 2 is 95. Number 3, people always miss. What's the answer?
200.
Everybody always says 200.
Wait.
This part is 200. But it's asking me for that part. ABC goes around that way. So I would have to do 360 minus 200. The answer is actually 160. You use the 200 to get the answer, but 200 itself is not the answer.
So you're going to subtract the whole.
If I'm looking at this one, most people get the angle S part. They don't miss that one. Because arc's on the outside. So I divide by 2 and get 30. Almost everybody gets that one, no problem. The part we miss is the second part. Well, if I take this 37, that's the angle. So I multiply by 2 and get 74 there, and people stop and not realize, well, it's asking me for RQ.
So subtract that.
RQ is over there. I need to realize there's a semicircle at the top. So I'll do 180 minus that 74 and get 106. All right, this first one up here says if 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. If I'm looking at angle A right here, what arc does it make on the other side of the circle? What arc does angle A make on the other side?
CD?
Let me say, maybe that'll help. It makes CD. Everybody see that? All right. What about angle B down here? If I take that one away, it makes the same one. So if those 2 angles hit the same arc on the other side, they've got to be the same. Angle A has to equal angle B. And then I can turn it around and say, well, what about angle C? Because it hits AB over there. And then angle D hits AB. So I know that angle C equals angle D. What you need to remember is the ones that are on the same side are going to be equal if it looks like that. For some reason, people get it messed up all the time. It's the ones that are on the same side. The one down here at the bottom should be very clear once you start seeing the problems. If a right triangle is inscribed in a circle, hypotenuse has to be a diameter. Why?
Bigger.
How much is this?
Nice.
And if I do an inscribed angle, how do I find the arc? If I have the angle, how do I find the arc? Multiply by 2. What is 90 times 2? 180. Well, what makes 180? Half a circle, which means you got to have a diameter. And if you see a diameter, then what does that automatically mean about this angle? It's got to be a right angle and got to be 90. So if you see a right angle, you know you've got a diameter. If you see a diameter, it's got to be a right angle. All right, this rule says quadrilateral can be inscribed in a circle if and only if the opposite angles are supplementary. What does supplementary mean again?
180.
Add up to be 180. So, what is it telling me adds up to be 180? If it says opposite angles. Which one is opposite from B? So that means angle B plus angle D is equal to 180. Do not,
So it'll be 90 feet.
no, it could be 180.
Oh, yeah.
It could be 105 and 75. Do not put them equal to each other. That is the mistake that people make all the time. Add them up equal to 180. But this is not the only one that adds up to be 180.
B and C.
That means C plus E also equals 180. All right. Again, if it says if and only if, what does that mean?
It works both ways.
So I know it can be inscribed if the opposite angles are supplementary. And I know if the opposite angles are supplementary, then I can draw a circle around it and hit all the corners.
You don't play really bad.
All right, if I'm looking at this first one, which two have to be equal to each other? Which angles? What? A and D have to be equal to each other because A comes across and makes BC, and then D starts here and comes across and makes BC. So if A is 27, then the angle D has to be 27. And then I go back, angle B has to match what?
C.
B
Yeah,
matches
C.
C. The ones on the same side are going to match if they make the arc the same across the circle. So that means C has to match B. And those have to be 32. That's the easiest problem that's going to be on the quiz and the test, and people miss it all the time. The ones on the same side match because they make the arc across the circle. If I go to the second one over here, angle B should be automatic. What is it? It's got to be 90. I know it's 90 because there's a diameter. Diameter means 180. Half of 180 means 90 for that angle. Because what kind of angle is it? What kind of more than that? No. That we talked about today. The new one that we talked about today. Inscribed. It's an inscribed angle. So it has to be half of the arc. The arc is a semicircle, so half of 180 is 90. AEC, how much is that got to be?
180.
It's a semicircle. That's automatic. All right, here's where we got to pay attention. A is 62. How much is arc BC across from it?
You do 180 minus
You gotta do
60, right?
Wait a minute now. I'm looking for arc BC.
That's the inscribed.
Multiply by 2.
Multiply by 2 because what kind of angle is that? Inscribed. Inscribed means multiply, or excuse me, if it gives you the angle, you multiply. So that would be 62 times 2 or
124.
124. Now it asks me for angle C. How am I going to find angle C?
Subtract 124 by 180 and then divide that by 2.
That is one way. I could say, well, if this is 124, I know the leftover part over here is 180 minus 124 and get 56.
56.
And then I could say 56 is the arc, so I divide by 2 and get
28.
28. That works perfectly fine. Another way of doing it is this. What did we say about angle B?
It's
90
degrees.
Well, there's a triangle, right? So if I'm looking at this right here, I got 90 and 62. I could add those up and subtract from 180. I'd still get the 28 there. And in arc AB We figured out with the 56. So depending on which way you do it, you can find the 56 first and then divide by 2 to find the 28. Or you can find the 28 first and then multiply by 2 to find the 56. Whichever way works for you.
You gonna let us use these already?
All right. If you ever see a quadrilateral inscribed in a circle, the inscribed means you got all corners touching the circle. The rule says the only way that can happen is if the opposite ones add up to be 180. So I've got to say that which ones add up to be 180?
A and C,
So angle A plus angle C
and angle B and angle D.
is equal to 180. And then angle B plus angle D is equal to 180. Well, what is angle A? 2x.
Yep.
What is angle C?
104.
104. There's my equation. I would need to solve that equation. So I would minus the 104.
Go too fast.
Learning too slow. So you wind up with x being 38. So I can fill that in. Angle A, how much is angle A then? How would I find that?
38 times by 2.
I know that angle A is 2 times x. X is 38, so this is 2 times 38, which is
76.
76. Come over and do the second part. Angle B is 3y. Angle D is 6y. And I know those two have to add up to be 180. So then I get 9y equals 180. Divide by 9 and y equals 20. Well, then how do I use that to find B and D?
You plug it in.
Take that 20 and plug it in for B. Well, B is 3 times 20, so that is 60. D is 6 times 20, and that is 120.